Hello everyone, welcome to Java session. Today's topic is collections. In today's session, we will discuss about Java collections framework, collections, sets, lists, and queues. Java collections framework. A collection allows a group of objects to be treated as a single unit. Objects can be stored, retrieved, and manipulated as elements of collection. So if you have a group of objects and you want to treat it as a single unit, then we can call it as a collection. So the best example, arrays. So arrays are an example of collection, one kind of collection. Like you have a set of integer values which are of integer array. Okay, so this is the best example for one kind of collection. Program design often requires the handling of collection of objects. So the Java collections framework provides a set of standard utility classes for managing various kinds of collections. So the core framework is provided in java.util package. So this collection framework is available in java.util package, and it comprises three main parts. Okay, the core interfaces that allow collections to be manipulated independently of their implementations. So these generic interfaces define the common functionality exhibited by collections and facilitate data exchange between collections. And a set of implementations that are specific implementations of the core interfaces, providing data structures that a program can readily use. So, and an assortment of static utility methods are found in collections and arrays classes that use to perform various operations on collections and arrays, such as sorting, searching, and creating customized collections. So, if you look at this hierarchy, these are the core interfaces. So, java.lang.iterable interface, which will take enumerated like any type of data, integers, characters, okay, and float, double, okay, these kind of various data types. And its subclass is collection, okay, interface, and list, queue, set, map. So these are the various interfaces that extends the collection interface. Collection interface extends the interval interface. And in queue we have dq, and in set we have sorted set, navigable set, and in map, sorted map, navigable map. So these are the core interfaces of this collection framework. And so these generic collection interface is generalized interface for maintaining the collection, and it is the root of interfaces inheritance. So collection, see here, a basic interface that define the normal operations that allow collection of objects to be maintained or handled as a single unit. So in set interface, what happen, like it will remove the duplicate objects. Okay, the set interface extends the collection interface to represent the mathematical namesake set of unique elements. Set is nothing but unique elements. And sorted set, which is in the sorted order. Navigable set, and which is extends the sorted set, and it is used to maintain the sorted set. Okay, and also list. So the order in which we have added, in the same way we'll get the values, sequence of the elements. Queue, so it will first in first out. And dq interface extends the queue interface to maintain the queue whose elements can be processed at both the ends. So dq is to process both the ends. Map, which is key value pair, so a basic interface that defines operations for maintaining mapping of the keys to values. And the sorted map, which is in the sorted order. Navigable map, which is used to this is extends the sorted map interface for sorted maps. So replace of sorted maps. And so iterable, iterator. So this collection is also iterator interface, and we have list iterator, okay, and dq interface. These are the classes, concrete classes. These are the implementations like vector, array list, linked list. So vector, array list, and linked list are part of list. And so set, hash set, tree set, linked hash set, and here dq, array dq. So these are the core classes of these interfaces. Core map interfaces, map and hash map, tree map, hash table, linked hash map. So interfaces as well as concrete classes. So every concrete class is having interface, like hash set is you know it was implemented by from a set interface, and it is having unique elements, no order, equals and hash code. Linked hash set unique elements insertion order, it will follow the order, and method set can be called on elements, equals and hash code. Tree set sorted set and unique elements sorted, and it has balancing tree compared to array list. Order will be the same, list allowed, duplicates allowed, and equals. Okay, like that. These are the what are the whether we can allow the duplicates or not, and what are the interfaces that these classes are extended, and what is the insertion order, and what are the methods that can be called on the elements. Okay, so list, queue, qdq, map, and sorted map. Next is collections. So the collection interface specifies the contract that all collections should implement. Some of the operations in the interface are optional, meaning that a collection may choose to provide a stub implementation of such an operation that throws an unsupported exception when invoked. If you want to get the size of collection, then you can use the size method, is empty and contains. If you a particular element is available in that list or not, you can use the contains method, and you can use add element, remove. So to add and remove method returns the true if the collection was modified as a result of operation. By returning the value false means it indicates that collection excluded the duplicates. So if it is true, then it is added, otherwise uh, it is not added. Okay, it is excluded. And bulk operations, like you can add bulk of objects into a collection, so bulk values into a collection object. So boolean contains all, and you can check whether this particular collection of objects are available in whole set. So this a dot contains all of b, and a dot add all of b, a dot remove all b, and a dot retain all of b. So you can use these contains all, add all, remove all, retain all methods, and for bulk operations. Iterators. So if you want to iterate the elements within a collection object, we can use the iterator interface. Okay, a collection provides an iterator which allows sequential access to the elements of a collection. An iterator can be obtained by calling the following method of collection interface. So iterator e of enumerated data type iterator returns an object which implements the iterator interface. So the generic interface iterator is defined as follows. So like has next, whether the next element is available or not. So if it is returns true, that means underlying collection still has elements left to return. So and next method will return the actual object. Okay, moves the iterator to the next element in the underlying collection and returns the current element. While remove, what it will do, it will remove the current element that was written by last call to next method. Sets. Set, we have already discussed that set is a collection object, and which is having unique elements. It doesn't have any duplicate elements. Unlike other implementation of collection interface, this implementation of set interface do not allow duplicate elements. This also means a set contains at most one null value. Okay, the set interface does not define any new methods, and it has add all methods will not store duplicates. Hash set and linked hash set classes. The hash set class implements the set interface. Since the implementation uses hash table, it offers near constant time performance for most operations. Hash set does not guarantee any ordering of elements. However, the linked hash set subclass of hash set guarantees insertion order. It is also the implementation of choice if frequent traversal over the set is necessary. A hash set relies on the implementation of the hash code and equals method of its elements. Lists. So lists are the collection of that maintain their elements in an order. So whatever order we have added, in the same order we can get the values, and it can contain duplicates, and a zero based index can be used to access the elements at the position designated by the index value. And the position of element can change, and elements are inserted or deleted from the list. So array list of e, or linked list e, vector e. So these are the concrete implementation classes of a list interface. Okay, the ArrayList class implements the list interface. Vector class is a legacy class that has been retrofitted to implement the list interface. So the vector and ArrayList classes are implemented using dynamically resizable arrays, provided fast random access and fast list traversal. So these are used to access fastly random access and fast list travel, very much like using ordinary array. Okay, and vector class is a thread safe, meaning even concurrent threads can also access the vector class, which is the thread safe. Queues. So queues interface extends the collection interface to specify a generic contract for classes. So a queue is a collection that maintains the elements in a processing order, like first in, first out. So whatever, if you add it, and it will be come first. So you can basic queue usually maintains its element in first out ordering, but the other orderings are also quite common, like lost in first out, stacks. We call it as a stacks, in which elements can be retrieved for processing is dictated either by natural ordering of the element or by a comparator. Okay, the queue interface extends the collection interface with the following methods called add of element and offer element. Priority queue, both priority queue and linked list classes also implements the queue interfaces. So there you can bidirectionally traverse the queue. Okay, and priority queue, you can construct priority queue of collection extends. So the default constructor creates a new empty priority queue with default initial capacity. So if you specify some initial capacity, then that much memory will be created, and you can add those values objects. Okay, so before we end this session, I would like to show you how these collection objects can be created and how can we add the elements. Okay. Here I have created a class called test. Okay. In test class, in the main method, here this is the list interface, which is part of java.util package, and so we cannot create an object for interfaces. So what we did here, we have created an object for array list. So array list is a concrete implementation of list interface. Okay, of and we can pass different data types. So this array list is an object of integer collection. It is integer collection. So list integer list equals to new array list. Now what we are doing is we are adding. So we can add primitive type, data type to the these objects also. So add integer list dot add of 1 3 5 7. Okay, I have added, and we are printing here. And in the same way, set integer set new hash set. Okay, so set, it doesn't contain duplicates, right? So what I did here, I have added 1 twice, 3 5 7. Okay, what will happen? So if we run as Java application here, see here in set it removed, whereas in integer list, if I add one more time, run as Java application 11357. So in list, so in list we can add duplicate elements, whereas in integer set we cannot add any, even though if you add, it will ignore the elements. Okay, and also iterator and of integer I. Okay, and integer list dot iterator method. So what it will do, it will iterate, so traverse the collection object. This iterator, what it will do, it will traverse the collection object. So now what we'll do for I, integer I, or else what I'll do, while I dot has next, system out dot println I dot next. So here it is printing 11357. So like this, we can add these objects. Okay, and so we can use a list, set, queue like this. So all these collection objects are used to uh, these objects are used to access this collection of elements like integer. If group of objects you have, and if you want to group them and use them, then we can use this collections framework. Okay, so if you have any questions or queries on this today's session, please mail us, or please mail us at info@bicourses.com. Okay, thank you so much.